National Unicorn Day today. Okay. Side note: need a calculator today if you didn't got one. Today's title of the lesson comes to you from the '80s rock group Rat. Round and round. We'll all find a way. Just give it time. Okay. Round and round. Round and round. All right. So we'll pick up from where we left off yesterday. Yesterday we did this problem on page 10 in your notebook. We ended up with, we were on a Ferris wheel. We were going counterclockwise. It had a radius of 30 feet. We went one revolution every 20 seconds. So we had to do some adjustments to our function, and we ended up with a parametric function that was 30 cosine of pi over 10 times t, and 30 cosine, oops, whoa, not cosine, tap the brakes, Lens, sine of pi over 10t, and then we had plus 40. And then our t values went from 0 to 20, but we also said that this number could be any number bigger than 20. Okay? The smallest that number could be is 20 because it took us 20 seconds to get all the way around the circle. Okay? Everybody remember that? So we're all caught up? Okay? All right? Today, we're going to make some tweaks to that exact same problem. Okay? And so we can, because not all Ferris wheels go around in a counterclockwise fashion. Okay? So if I'm sitting here and I'm looking at a Ferris wheel, let's say that there's a Ferris wheel right here between me and Regan. Okay? Right? So we're going around like this, right? It's going counterclockwise for me. Which way is it going for you? It's going clockwise, right? Yep. Okay? So it depends on which side of the Ferris wheel you're looking at, right? So we got to be able to make that adjustment. Okay? And how we make that adjustment is, remember, we had x of t being a cosine of b times the quantity x minus c plus d, and we had y of t equaling a sine of b times the quantity x minus c plus d, right? So to make it go the other way, to make it spin clockwise, that would be a negative b value. So we make b be negative in order for it to spin clockwise. Okay. Now, I'm going to go out on a very large assumption. I am going to assume that all of you have ridden a Ferris wheel at some point in time in your life. Am I wrong in that assumption? Has everybody ridden on a Ferris wheel? Okay? Where have you loaded to get on the Ferris wheel? At the bottom, right? Typically at the bottom, because that's ground level, right? You might have to step up on a little bit of a platform to get on, okay? On some of the bigger ones, they have like 3 or 5 loading stations, right? Yeah, like the one in the Mall of America has 3 loading stations. So it loads 3 cars at a time. The one at Bay Beach loads 1 car at a time. Okay? The cool one that I went on in Cleveland loaded 5 cars at a time. Okay? Right? Or gondolas, whichever one you prefer. Okay? Right? So we have to adjust for, instead of loading here at 0 on the unit circle, we have to adjust for loading at the bottom. Or in the $1 billion idea that I had about the aquarium one, we would load at the top. Okay? Right? So to adjust that, or account for that, I should say, we have C values here. Okay? So if we are loading at the top of the Ferris wheel, then our C value would equal pi over 2. Now I got to think here. I got to remember, is it pi over 2 or no, because it's inside a set of parentheses, it's going to be negative pi over 2. All right. After some consultation, I forgot it's the one that's goofy. So it's our C value would be plus pi over 2. Okay? Or here, our C value could be negative 3 pi over 2. That will also get me to the same spot on top. Okay? Pi over 2 here on the unit circle is straight up. If I went the positive direction, if I go the negative direction, it takes me to that. Okay? If I'm at the left side, my C value would be positive pi or negative pi. If I'm at the bottom of the Ferris wheel, which is the most common, my C value would be positive 3 pi over 2, or my C value would be negative pi over 2. One of those two. Okay? Or if there's, like we were talking about, all those different cars loading at different ones. If you loaded your gondolas at 7 pi over 4, 5 pi over 4, and 3 pi over 2, you know what I mean? So you loaded 3 of them at a time, okay? So if you load it here, then that would be plus 7 pi over 4, or minus pi over 4, and so on and so forth, whatever that unit circle angle in radians is at that loading point. Okay? With that being said now let's get on a Ferris wheel that has a radius of 60 feet. It has a period of 12 seconds. The bottom of the Ferris wheel is 8 feet from the ground. It is rotating in a clockwise direction, and you load from the bottom. Okay? A lot of information there. Let's decipher. First off, let's find the parametric equations. So I am 8 feet off the ground. Then I have a radius of 60 feet. Which would put my center of the Ferris wheel where? Where would my center? 0, 68. 0, 68. Okay. It has a period of 12 seconds. Yesterday we learned that our B value was equal to 2 pi divided by the period. So that's going to be 2 pi divided by 12, or pi over 6. Correct? Because it is rotating clockwise, our B value then is negative. So my x part of the parametric function should be 60 cosine of negative pi over 6 t, right? I'm loading at the bottom. So do we want to go with a C value of negative pi over 2 or positive 3 pi over 2? Negative pi over 2 was the first one I heard, so let's go with the C value of negative pi over 2. So then this would be minus, oops, got the bricks. minus pi over 2 there. My y is going to be 60 sine of negative pi over 6 times t minus pi over 2, and then plus 68. What are my t values that I can plug in? Zero to 12, but this 12 number could be anything bigger than 12, correct? Everybody agree with and know how to decipher where I got everything from for making our equations? Graphic. Should be something like that. Then when we go to graph it, we are going to have to, come on. We are going to have to adjust our window for x's. We're going to need to go out to at least 60 because we have a 60-foot radius, so I'm going to go 70. For y's, we don't need to be negative, but I do like to see the ground. And maximum, we would need to be up at 128. So I'm going to go 150 there and go by tenths. Now it doesn't look like a Ferris wheel because, again, it's not square. So if I zoom square it up, now that I've at least found it, what did I just do? What? To make it look normal, zoom square. It's B. It's way down at the bottom when you go window zoom. It's all way down at the bottom. But you could just type B once you get into that drop down menu. And then to make it fit all in there, then I grabbed onto my axes and I pulled my axes a little bit. Huh? Yep, makes a difference. All right? Everybody got it? All right, so let's ask some questions here now. Question number 1 says, what is the location of the gondola when t equals 5? Okay, so we can go to our graph and we can trace it, and we can trace it until we get to 5. Okay, whoops. Oh, what's going on here? T equals 0 when I'm there. What's going on here? Shouldn't I be at the bottom? Shouldn't I be at the bottom at 0? Okay, so what did we do wrong? Let's problem solve this. What do you think it should be? Plus pi over 2? Okay. So what's wrong? Are you guys at the bottom? No? At t equals 0? Oh, yeah, you have the extra set of parentheses? All right, let's see if that extra set of parentheses makes a difference. Okay? Okay, so now we're hoping that we're at the bottom. Okay, so we're at the bottom, right? Let's just do a test here now. Which way should we be going? Clockwise, so it should be after we take off, it should go to the left, right? Okay, that's good. Okay. When I'm at the side, I should be at how many seconds? 3 seconds, and I should be at the side. Okay. 6 seconds, I should be at the top. 1 too many. Okay. Yep. Good there. All right. So after 5 seconds, what is our position? We just type in 5. And so what would our position be then? Or more importantly, I should say, how should I write this position? How should I write this position? "30 feet left of center." And 119.96 feet above the ground. Bless you. Okay. What's up?
We always drop the negative, no matter what. Like on 30, like negative 30.
Because we're looking at it, yes, it's a distance, so we can't have negative distances.
Also, I got I didn't go.
That's how you round it. Okay. What about when t equals 47? I can't type in 47. I get an error. What do you got? Because it's only up to 12. So what should I type in instead? What was that? I can change my t values to something bigger than 47. That's one option. And then I could type in 47. Or I could type in 11. Okay? Because 47 seconds is also 11 seconds in terms of positioning on the Ferris wheel. So then at t equals 47, we are 30 feet right of center and 16.038 feet above the okay. Question C. How far have you traveled if you were to ride for 1 minute? How far have you traveled? How many do? What? Okay, how many circumferences did we go? Went 5, because it takes 12 seconds to get around. So in 1 minute, we went around 5 times. So we went 5 circumferences around. So how far did we go? What's the formula for the circumference of a circle? Say louder, Carlos. 2 pi radius. What's my radius? 60. So we ended up going 600 pi feet, or approximately 1,884.956 feet. Okay? Page 12 now. Answer me those questions.
values.
Okay, because we're loading at the bottom, right?
Yeah, so.
So I could go plus 3 pi over 2, or I could go minus pi over 2.
Well,
same thing.
For
For bottom,
and
yep.
in front of the bottom.
Yep. Agree with me on my parametric function. Yeah? Okay. All right. Let's get this in here then. So we said that this was 80 and 80. This was over 8. This was over 8. Here we went there this time instead of minus pi over 2. Could have done minus pi over 2 also. And here these switched around to 86. This has to be 16. Okay. Okay. There it is. Love it. First question is, what is my position 2.5 minutes into the ride? Okay. 2.5 minutes is 60, 60, and 30, right? So 2.5 minutes is 150 seconds. Yes? Okay. So 150, so if it takes 16 seconds to get all the way around, correct? Okay. So that means the closest one then would be 144. Okay. So this would be a t value here of 6. Now I could also have made my t value bigger than 150 and then just traced it to 150 also. But if we wanted to, we could just do a t value at 6 seconds. That's this way, menu, trace, 6. Okay. So we are 56.569 feet left of center and 142.57 feet above the ground. Okay. 4 minutes. 4 minutes is 240 seconds. Yes? How many revolutions did you do in 4 minutes? How many revolutions did we do in 4 minutes? 15 revolutions. So that's 30 times 80. So that's 2,400 pi feet. Or 7,539.882. 7,539.882. 7,539.822 feet. So you went almost a mile and a half. 4 minutes. That's actually kind of moving. Good. Cue number 2 should be on the next page. So I got those for my parametric equations from the start. I can't fill in what C is yet because C is going to change if you read B, D, and C, parts B, D, and or B, C, and D, that C value is going to change with each one. Okay? But that's the basic general function there for our parametric equation. Okay? So if we load from the top then, our C value here then would be plus pi over 2. And so we'd have to fill that in, and then we could go about doing that. Now, it's only asking for how high we are above the ground, correct? Okay, so that's only going to be the y1. So really what we could do here is we could just say y of 56 is equal to 40 times the sine of 2 pi over 15 times 56 plus pi over 2 plus 52. I don't even need to graph it. I can just use the parametric equation and plug 56 into my y of t and make sure that c is positive pi over 2. Forty sine of 2 pi over 15 times 56 plus pi over 2 plus 52. So you should get the fact that you are 47.819 feet above the ground. Yes? If you load the Ferris wheel at the bottom, now my C value is going to be negative pi over 2. How far are you above the ground? 27 seconds into the ride. Well, that would be y of 27 is equal to 40 sine of 2 pi over 15 times 27 minus pi over 2 now, plus 52. $39.639 feet above the ground. If the operator of the ride eats a sandwich for 5 minutes and forgets to stop the ride, how far have you traveled? Well, so you're going around how many times a minute? 4 times a minute, because it's 15 seconds to go around, right? So how many times total have you gone around in 5 minutes? 20 times. So that's 40, so that is 1,600 pi feet, or approximately 5,026.548. 5,026,548. Okay. Good times.